All right, welcome to the next video for Unit 8. We'll start out by solving logarithmic equations. Actually, exponential equations, sorry. The first ones we will solve by changing them to be the same base. So for example, we have 3 to the x here, and 1 over 27, that is the same as 3 to the negative third. All right, because basically it's 1 over 3 to the third. And then once you have the bases the same, notice the bases are the same here, you can drop the bases and solve for the exponent. So the first thing you want to do is make the bases the same. And then the second thing you're going to do is, once they are the same, is you'll set the exponents equal to each other. And then solve. So here we have x equals negative 3 because you just set them equal. So for the next one, 8 and 4, the common base is 2, so this is 2 to the third, so it's 2 to the 3x. And then 1/4 is 2 to the negative second. So here 3x equals negative 2, so x equals negative 2/3. So here it's going to be a power of 2. Remember, 32 is 2 to the 5th, so you have the cube root of 2 to the 5th. And then remember, it's fractional exponent's power over root. So then x equals 5/3. So here it's going to be 3, so 3 to the third. And then, actually, sorry, 3 squared. 9 is 3 squared. And 27 is 3 to the third. So we have 2 times x minus 3 equals 3. So 2x minus 6 when we distribute. So 2x equals 9, and x equals 9/2. You can make these powers of 4 or 2, because 4 is a power of 64 is a power of 4. So we'll make it 4, just keep it simple. So this is 4 to the third. And then x minus 2 equals 3x. And then we subtract x. So we get negative 2 equals 2x. Negative 1 equals x. Here, same thing. You could either keep it as power of 4 or make it powers of 2. So it's going to be 2 to the x plus 5. Or sorry, 4 times 4 to the 2x plus 5 equals 4 squared to the x plus 1. So then it's 2x plus 5 equals 2x plus 2. So then when you solve here, it gives you 5 equals 2. That means there is no solution. That means there is no number that will make that possible. So here 4 to the x equals 15. Now 4 and 15 are not a power of the same base, so this is where we will need some way to solve for the exponent, and that is why logarithms come into play. So logarithms will help us solve that, which we will eventually do in one of the other learning opportunities. So definition of a logarithm. So logarithm, you have a base, you have an exponent, you have an answer. So remember, this is the base, exponent, answer. So base, so it's 3, exponent is 4, equals 81. That is in exponential form. So remember, logarithms are exponents, meaning they're equal to the exponents of the base. So here it's 2 to the first equals 2. 10 to the negative third equals 0.001. That is translating it from a logarithm to an exponential form. So here we're going to do the reverse. We're going to take it and make it from an exponential form into a logarithmic. So first the base is 5. So log base 5. The answer is 125. The exponent is 3. Remember, it always has to equal the exponent. So here the base is 8. So log base 8 of 1/4 is equal to negative 2/3. Now, whenever there's a radical, you want to make it a fractional exponent. So for example, 5 rad 5, that's the same as 5 times 5 to the 1/2. Well, 1 plus 1/2, because remember 5 to the first, so that's actual 5 to the 3/2. So basically here you say log base 5 of 5 rad 5 is equal to 3/2. So you translate it. Base exponent is here, and base exponent and then answer. So when you're solving or evaluating a logarithm or simplifying it, so for example here, you're basically trying to figure out what is the exponent. So 5 to what power is equal to 625? Well, 625 is 5 to the 4th, so that means it's equal to 4. So like for number 9, 4 to what power is 1/64? Well, 1/64 is 4 to the negative third, so this is equal to negative 3. Here, you're saying 2 to what power is equal to 0.125? Well, 0.125 as a fraction is 1/8, and 1/8 is 2 to the negative third, so that means it's equal to negative 3. So here, 4 rad 2, so basically 2 to what power is equal to 4 rad 2? Well, 4 is 2 squared times 2 to the 1/2, which is rad 2. So when you add those, you get 2 to the 4/2 plus 1/2, so 2 to the 5/2. So 2 to the x is equal to 2 to the 5/2, so that means that this has to equal 5/2. Solving an equation here, and this is basically what we did here, so 4 to the x is equal to 2. Well, remember, 4 is the same as 2 squared, and this is 2 to the first, so 2x equals 1, so x equals 1/2. So x to the negative first equals 5. So now, what number to the negative first power is equal to 5? Well, you could change this and make it 1/x equals 5. So then when you multiply by x, you get 1 equals 5x, and 1/5 equals x. Nine to the 3/2 equals x is what happens when you translate it. Well, 9 to the 3/2, remember that's the square root of 9 cubed. So that means it's 3 to the third, which is 27. And then here, last but not least, 1/2 to the negative second. So that means it's 1 to the negative second over 2 to the negative second, which means you just basically take the reciprocal, since it's negative exponent, So it's 2 squared over 1 squared, which means it's 4. All right. I hope you enjoyed this video, and we'll start talking about common logarithms and the properties of logarithms next.